All right, today we are deconstructing a really serious piece of engineering. I've got the tech specs and the diagrams for the QSC RSC112 right here.
Mm-hmm.
This is the kind of hardware that, it lives behind the screen in a cinema or a high-end mixing stage.
Yeah.
It's technically a three-way screen channel loudspeaker.
Yeah, but that name doesn't really do it justice. Looking at the architecture, this isn't consumer gear. This is the core of a high-performance reference monitor system.
And that word reference, that's the key, isn't it? We're not looking for a speaker that adds a nice warm sound to things.
No, not at all. This is a tool for what they call critical mixing. The whole point is brutal honesty.
So if there's a problem in the mix, a flaw in the dialogue track or something,
This system has to reveal it, not hide it. The engineers, they have to trust that what they're hearing is the absolute truth of the audio file.
okay, so let's get into how they actually achieve that truth. I was looking at the design, and it's listed as triamp.
Right. 3 distinct drivers.
And the low-frequency part, that immediately jumped out at me. You got a 12-inch woofer, sure, but it's matched with a massive 4-inch voice coil.
And that 4-inch coil is the real story there. Most drivers that size would, settle for a 2.5 or 3-inch coil?
Yeah.
By going up to 4 inches, you just dramatically increase the thermal power handling.
Which means when you're pushing the system hard, and the specs say it can hit peaks of 132 decibels, the driver itself doesn't heat up and start compressing the sound.
Exactly. It minimizes what's called power compression. So the kick drum you hear at a low volume has the same punch as it does at reference levels. It keeps the bass tight.
Okay, so moving up the frequency spectrum, we get to the mid and high frequencies. This is where that coaxial neodymium compression driver comes in.
The magic bullet.
Instead of having separate horns for the mids and highs, they've mounted the 3.5-inch mid-range and the 1.75-inch high-frequency driver on the same axis.
And for a reference monitor, that physical alignment is it's non-negotiable.
Why is that so critical?
Because the sound originates from a single point in space, a true point source. You completely eliminate the phase issues you get when the drivers are separated vertically. It just makes the crossover between mids and highs basically invisible.
I noticed the spec sheet made a point of saying this design avoids dome breakup.
Ah, yeah. That's a huge problem in a lot of standard drivers. At really high frequencies, the diaphragm itself can start to ripple or warp.
Like a cracked bell.
That's a great way to put it. And it creates these really harsh metallic sounds. The polymer they use in the RSC112 is engineered to stay rigid, so the top end sounds transparent, not painful.
So, okay, we've got the sound perfectly aligned at the source. But that doesn't mean much if it just scatters randomly into the room. Right?
That is the classic challenge. You have to control the dispersion.
And that must be where this DMT, the directivity match transition, comes in.
Yes. The simple explanation is that it matches the coverage angle of the big woofer to the horn right at the crossover point. There's no sudden shift.
What does that actually do for the listener, though?
It creates this really smooth, predictable 90-degree coverage pattern. So the mix doesn't sound totally different depending on where you sit. The person at the mixing desk and the producer on the couch at the back, they're hearing the same tonal balance.
And it's all housed in this 15-ply Baltic birch enclosure. I saw the shipping weight is over 30 kilograms. That is a lot of wood.
It has to be. It's necessary mass. That enclosure needs to be completely inert, If the cabinet walls start vibrating, they become speakers themselves, and that colors the sound.
So the heavy-duty box keeps all the energy focused forward.
Exactly. It doesn't let the box rattle itself to pieces.
It really frames this thing not just as a loudspeaker, but as a precision instrument.
Yeah.
This is the standard creators are using to actually sign off on their work.
It is the final checkpoint. When a director says, print it for the sound mix, this is the system they're listening on.
Which I think brings us to a kind of sobering thought about how we all listen to things. This piece of hardware is capable of insane dynamic range, perfect phase coherence. I mean, if this is the level of precision required to make the art, how much of that detail, how much of the engineer's work are we just completely missing when we listen on earbuds or a TV soundbar?
We're probably losing the very texture that makes it feel immersive. All the subtle stuff is just gone.
Something to think about the next time you queue up a movie.